Okay, we will go ahead and get started. Thank you all for joining us today for the next webinar in the Port of the Future series, assessing maritime transportation systems from a consequence-based cyber-informed engineering strategy. Certainly a very timely topic. I want to first remind all of our attendees that the slides and recordings will be made available to you after the webinar. We will email those out later this afternoon. Additionally, there will be an opportunity to have your questions answered at the end, so please feel free to ask your questions as they arise by typing them in the Q&A box at the bottom of your screen. Reminder, the earlier you ask them, the more likely they are to be answered, so we will certainly aim to answer all of them, but earlier is better. So let's get started. And here for today's session is no stranger to the Port of the Future Conference, Marco Ayala, Director in ICS Cybersecurity and Sector Lead at 1898 & Company, part of Burns & McDonnell, and Andy Bochman, who is the Senior Grid Strategist for Idaho National Laboratories National and Homeland Security Directorate. Andy and Marco, the virtual floor is yours.
Wow, Kyle, thank you. That was a nice introduction. And everybody, if you can just hold on for 2 slides, you'll get to see a picture of what Marco and I look like dressed up. Today I'm in lumberjack mode. And what are you again, Marco? You're visible to everybody, right? What are you wearing?
I'm actually in a fire retardant jumpsuit for going into plants and refining environments. And also offshore activities. So yeah, it keeps me safe.
Well, you're in a little tiny box, and so it's possible some attendees might not be able to make that out if they didn't know. But to me, it lends a certain authenticity to our ability to talk on this topic. Let's see if that turns out to be real. Let's practice the next slide maneuver. Next slide, please. So when you see the next slide, there's a question we want you to keep in mind, is will ports of the future be targets to cyber adversaries of various stripes? Do you think they will be, or do you think, nah, they're just not interesting enough or important enough? Probably cyber adversaries will go somewhere else, but not port operations or things like that. So we'll leave that hanging in the air. What is the likelihood that ports will be targeted? Marco, anything before we get to go to the picture where we're dressed up?
No, I think this is a good question to pose, because we definitely hear different sides of this question many times, especially out in the field. It's like, we're not a target. So I'll let you move up to the next slide.
Maybe ports of the present don't think they're targeted. Maybe only in the future you'll be targeted. So anyway, there's Marco with a tie, and I didn't get all the way to the tie stage. But I am significantly more dressed up than I am now in my upper Midwestern flannel shirt. I'm dialing in from Milwaukee, which is a home of many industrial companies, notably headquarters of Rockwell and Allen Bradley. Rockwell ate them, and Johnson Controls. And Marco, I'm in a northern latitude. You're in a southern latitude somewhere, I believe.
Yeah, I'm actually in Pascagoula, Mississippi, at a shipyard right now doing an assessment. And so, yeah, that is me in a suit and tie and my InfraGard lapel pin. So, yeah, that's me sometimes, not all the times.
Hardly ever. But anyway, just so you know, Marco and I don't think we have a slide on this, but the reason why you see the INL logo and the 1898, which if you can really squint says Burns McDonnell below it, we have become partners around this methodology that we'll be describing, Marco, in more detail in the second half as we go through here. Kyle did mention it's focused on consequences, and so you'll hear that thread too. So here we are at the mainly Andy section, although Marco is welcome to be an interloper anytime he has something of substance to add, or just a joke. And for all of you, in case we didn't say it earlier, we invite you to throw questions or comments into the chat area, Q&A area, and we'll try to get to those and get to most of them if we can before this thing is a complete wrap. So next slide, please. Recalibrating risk. What does that mean? And that question about will ports of the future be, see, I'm talking, it's slower to allow for the slide to change. Will ports of the future be targeted? And one way of answering that is, well, what about ports of the present? Are they targeted? And so the answer is apparently this has happened, and this is just one of the more noteworthy ones and one of the more approximate ones. But ports have been targeted in the past, and you can, I don't want to give the whole story away. I'd say just based on the fact that it's happening now and that it's happened in the past, you could potentially project into the future. That's the way we predict the future sometimes, and say, yep, we need to prepare for this. If anything, we need to prepare better than we can. But there is a certain litmus test we subject to any asset, any critically infrastructure, any national asset before we wonder about whether it's a target or not. Next slide, please. I had a little Freudian slip there that kind of screws up this next slide. So are ports considered part of critical infrastructure? I mean, they're not electric utilities. They're not an oil or gas company, refinery, midstream. They're not out looking for more oil, natural gas. They're not pipeline. So they're not those things. What else are they not? They're not critical communications nodes. So they're not that. And they're not banks. So are they part of critical infrastructure? We could turn to DHS in the United States, who has the responsibility for naming what is, and by omission, what is not critical infrastructure. So let's think on that. Now, you can probably, even if you have subtle snark detection, you can probably tell that I'm being a little bit sarcastic, but I'm trying not to be too much, because there's all kinds of different people in the audience, and some people take things the wrong way. And also, we can only infer that that there's all kinds of different people, levels of understanding and maturity. Some people know something about cybersecurity, but nothing about ports. Some people know a lot about ports, but cyber is a relatively new topic to them. And we do want to speak and offer something of substance to those two extremes and everybody in between. So let's move forward. I'll try to tamp down on my.
And one of the things before you move forward, Andy, is the fact that we do talk about product movements. So whether it's pipeline, whether you're moving oil, you're moving gas, natural gas. When it comes to transportation, it's all about movements, whether it's people, products, cargo, even fuels, many different things that that are important. Even humanitarian missions, trying to get in and out of ports. These are critical infrastructure. So I'll let you move on.
For sure. And again, that was just teasing out the obvious, and Marco drove it home. These are among the most critical infrastructures that we have, if you had to rack and stack them. They're not as numerous, right? We don't have as many ports as we do substations or refineries. But the ones that we do have in the United States and worldwide are super important. Next slide, please. Here's an example. So a little background on my INL colleagues. Part of the complex of national labs in the United States. And they're all a little bit similar, and they all have differences. And the things about this lab is it's one of the birthplaces of nuclear energy research, development, and testing. It's where, improbably, and I won't explain why, it's one of the birthplaces of the nuclear Navy, with an emphasis on the nuclear aspect. And a lot of my colleagues on the cyber side, which I posit emerged from their immersion in nuclear topics, come from non-defensive backgrounds, non-defensive cyber operations backgrounds. So they're used to looking at other pieces of infrastructure in other places and seeing if there's any ways in. And from what they've shared, there's always ways in. So many. It's sort of a golden age to be a cyber attacker, whether it's a nation state level thing or the business model of all time, of our times anyway, ransomware. One thing they've shared with me in the past and continue to say is the following. And Dale Peterson of Digital Bond and S4, his objections notwithstanding, they say critical infrastructure. If you are critical infrastructure, you will be targeted. We've already driven that home, I believe, that ports are critical infrastructure, perhaps among the most critical. So accept that you will be targeted, that you are targeted. The second part of this mantra is that if you are targeted, when you are targeted, you will be compromised. It doesn't say you might be compromised. It doesn't say if you have really good defenses and you do all your best practices and you conform to the appropriate standards and you hire a really good chief security officer and you give him or her a great budget, then you might not be compromised. It doesn't say that. It says when you're targeted, because you're critical infrastructure, you will be compromised. What does compromise mean? It means that the perimeter defenses that you've erected, such as they are firewalls and VPNs and maybe some intrusion detection system ladled on and getting some training for your folks, those things need to be good. They need to be as good as they can be. If certain people come calling, they will pass through those things. And Marco will tell you what you can do once you understand that to be the case. Next slide, please. It's not the end of the story, is what I'm trying to say. It's the beginning of this story. So let's talk about likelihood. And here, again, some of my sarcasm may resurface, and I'll try to tamp it down. But you have to be exposed to this. I'm sorry. So I hope you can handle it. So in the classic risk equation, there's different words you can use, but it ends up being, and people are always trying to figure out what their risk is so they can know how much to spend or prepare against those risks of any different type. Hazards also, right? All hazards. Well, so if you had a risk, you want to figure it out. So you want to use math, you want to use numbers. And so it's typically cast as likelihood times impact or probability times consequence. Like, is the thing going to happen? And if it does happen, how bad is it going to be? How much is it going to hurt us? And people spend, and here's NIST speaking to you about how to think about the likelihood part of the equation. And they start to give you some feeling that you can go after this. The third bullet, go ahead and pick a method, pick any method. And whatever it is that you like to use to determine likelihood, go for that. And then get some more science into it in the fourth bullet, empirical data, statistical analysis. That will help you to determine the likelihood of a threat event occurring. So NIST is only egging you on to say you need to determine likelihood, and there's a lot of different ways you can do it. And however you choose to do it, you go for it. And next slide, please. Marco, were you going to say something, or was that just a throat clearing?
Now it was a little throat clearance, but when we start talking about likelihood, Andy, you and I have talked about this for some time. So I'm ready for your next slide, because I think you dive into some of the objective math and discussions around it.
We'll see. I start to break out in hives, but hopefully my picture's small enough you can't see that. So here, this is just an example of somebody that was encouraged to determine the likelihood of some attack that could hurt them in some way. Not for their entire enterprise, not for just one sector, but just for one database. And we get into math here that quickly outstrips the present version of me to understand it. I think way back when at the Air Force Academy, when I took multiple calculus classes, I think I could have worked my way through this. But now I'm I'm seeing integrals and derivatives, and I'm feeling like, good God, who can do this? And then if they can do it, how much confidence will we have that that's reflecting reality? And by the way, how much time is this going to take? Do I have to do this for all my applications? Do I have to do this for all my networks and my other most important processes? If that's the case, how am I going to have time or money to do anything else? Right. Next slide, please. There's going to be a couple of these, so hang in there. Here we have the mighty Richard Feynman. Some of you know him from the Space Shuttle Challenger O-ring commission, and he's done many other great things too. He's a person who lives and breathes the world of mathematics, statistics, and probability. We, at least at INL, even though I'm surrounded by very brilliant scientists and engineers, we don't have Richard Feynman at our disposal, and if we did, we'd only get a fraction of his time. I would posit that most people in port operations and in their vendors and in their partners, they don't have access to Dr. Feynman or any of his peers either. But nevertheless, though we don't have that talent, our tribe does spend a fair amount of time, which turns into money, calculating likelihood. Next slide, please. Another part that sometimes is factored into the risk equation as part of likelihood is we try to get into the heads of the adversary. And we try to think, I don't know, I don't think we're very successful at this when we do this, but like, I don't think, and I'm not going to name the countries, but I don't think country X, Y, or Z would attack us because of the following reasons. Assuming this is someone with some geopolitical knowledge and they understand which way the winds are blowing at any particular time. But they come up with an explanation that satisfies themselves and that sometimes they can attempt to satisfy their CEO or their board with, or their regulator with, why it's just not likely that they're going to get targeted by the adversary. I'd say, first of all, that's a fool's errand when you're talking about nation states. And secondly, if you're talking about ransomware, they're going to target you because it's money and it's a fantastic business with very little chance of getting caught. So it's kind of hard to talk this away. And as the asterisk says at the bottom, we don't know and we don't get to choose this. Anybody starts talking to you about understanding the intent of who would attack you, I would beg to differ that that's a worthwhile pursuit at all. Next slide, please. Yes. And all of us do these things. It's not like likelihood, other than what you saw with Dr. Feynman and the blackboard. It's not like it's rocket science. We all do these things every day. You know, this is the chicken crossing the road, and I don't know if anybody knows what the eyesight of chickens is. I didn't grow up in a very agrarian household, so I don't really know. But the idea that, you know, whether you're washing your hands or brushing your teeth or looking both ways or wearing your seatbelt, all these various things that become habit after a while, so you don't have to think about them. If you did have to think about them, they would overwhelm you. So pretty quickly, we take it as second nature that we understand what likelihood is and we proceed accordingly. This chicken, though, here, we're talking about consequence. And I don't think he or she, I can't sex this chicken from this distance. I don't think it's a rooster. Marco, can you help me?
I dropped out for a second. I'm trying to get back online here, so I missed your last part.
All right. Anybody want to put the sex of this chicken into the chat room? We can find out. But let's just say that this chicken, a non-gendered chicken, is dealing with a heavy-duty consequence and probably knows not the likelihood that it's facing either. Depends on time of day. Next slide, please. I don't mean to beat you to death on this, and this is almost over, so hang in there. Our risk tolerance varies, and that's true for whichever part of the port you play a part in, whether you're on the vessels, whether you're running the cranes, whether you're part of the communications, whether you're part of management, whether your part of the job is to go from the offloaded containers and get them on trucks or get them on trains, and then keep those folks moving all the way across the country. Our risk tolerance varies greatly. We have examples on this slide, including Frogger in the lower left, if you're not familiar with that, where nothing gets me all worked up, like when I'm trying to decide whether I can make it past that truck or not and get onto those turtles in time to get onto the log. It's really a tremendous game. And maybe everyone should have to use that game as part of this process. But suffice it to say that our risk tolerance varies, that we're not very good as a species for doing it. And that means that if there's something that you want to base your decisions on, something you can take to the bank, it's probably not going to be likelihood. Next slide, please. Right? This is the way I look at it. This is the way I figure both the chances that you're going to be able to determine likelihood at all, and then two, that once you come up with a number, what's the confidence you should have that that's actionable? To me, it's a lot like spinning this wheel. Next slide, please. And think about it. When you're wrong about likelihood, some people I find still are not familiar with the Maginot Line. And maybe it's an age thing, maybe it's a schooling thing. But the Maginot Line, so I'll say it, is the famous, extremely expensive series of border walls and gun emplacements aimed at Germany from France after World War I to keep World War I from happening again. The problem is The folks that built it, they figured the likelihood that the Germans would have to come one way and one way only was very high. So they went to all this trouble to build the Maginot Line. Well, you can see from the upper right-hand corner, Germans like, no way, we're not going at that thing. We're just going to go around it. And hence they did. And hence this thing became sort of a laughing stock. And it's also a good business metaphor too. Might be a metaphor for our times. If you put too much stake in likelihood and you're wrong, it can be disastrous. Next slide, please. Okay, we're coming down the home stretch on this indictment of trying to go after likelihood, and we'll get some space open up for Marco in a second. So here we have our favorite Marine Corps general with a couple statements. You can't handle the truth that likelihood is not knowable with enough accuracy or precision to be helpful. He didn't say this. I'm putting these words into his mouth. And that probability, which is like likelihood, is always changing. So even if you think you nailed it on one day, the chance of being right the next day, and you wouldn't know on either day, is extremely low. And I show a couple examples of things that are kind of important in Houston, for example, like these 100 or 500 year events, which are now happening every other year. And those phrases are losing a bit of credibility. Next slide, please. I introduce you to General Michael Hayden and his point. For those people that are wishing and hoping and praying that their network defenses are good enough to keep away all manner of would-be cyber attackers and adversaries. General Hayden said a few years ago, they're going to get in, get over it. It's a very CCE-like attitude. They're going to get in, which is all like they are in. So now how do you want to be? Think like an engineer. How do you want to handle that if you know that people who do not have your interests in mind are in your systems and in your networks and are studying the way you do business? I think we're almost done. Next slide, please.
Yeah.
We are actually done.
Yeah.
And now we are on to Marco.
So you everything that you've spoken about, especially likelihood, I've had to deal with in the past. Well, pretty much my adult working life, especially working in chemical plants, refineries, midstream, and obviously now in the maritime space is the engineering side of it always wants to try to quantify, try to linearize what are my risks? Is this a 1 to 10, or are we a 2? Is it demonstrable that we are a 3? And so we're always trying to enumerate this, and especially when you're doing security risk assessments, PHAs, things of this nature, where you do have math and you're trying to map that into your corporate risk matrix. And with cyber, it's so different. It's much different than knowing if an instrument is going to fail at a certain time because it's been operating for X amount of man hours, as opposed to an adversary trying to get in and try to disrupt or degrade your systems and services. And that's the key piece of this consequence reduction strategies. Next slide.
I was going to say, or even weather, because weather there are historical patterns, albeit they're changing. But thanks to modern forecasting techniques, you can see it coming. You can get a feel for how strong it's going to be, and where it's going to land and how long it's going to linger. And you can see when it's gone, whatever the extreme event was. Right. With cyber, you have none of those advantages. You can't see it coming. You don't know how long it's going to last. And when it seems like it's over, it might not be over. That just may be a momentary pause to let you relax and start talking among your friends in ways that are monitorable by others. Because the cyber adversary is adaptable. They can adapt to what you're doing and change their game mid-course. Okay, sorry about that.
And they have the time and they have the resources, and depending on whether it's nation state or even just cyber actors wanting to make out money-wise, Bitcoin or whatever it may be, right. Or if they actually just want to have the intent to kill your organization from operating, if this is something that's more detrimental than just getting paid or what have you. There's other pieces to it, like hacktivism, are key things there. So yes, next slide. This is something that Andy, you put into the slides, and I've known Michael for many years. Post Y2K, Michael was a good friend of mine, and he was the co-originator for the consequence-driven cyber inform. May he rest in peace. And he stated that it is time to recognize how traditional engineering practices have fully absorbed cyber technology across the full engineering life cycle. And that's such a well put statement there. And for those that knew Mike Asante, he was just a genuine guy, wonderful guy, helped me out personally in many ways than most know. And so I think the foot forward here with CCE is important, especially from the engineering aspect of it, especially with the digitized systems that we're using and deploying today, from everything from crane control, autonomous vessels, remote control, remote monitoring. All these things have a cyber flair to it. And we have to make sure that we are engineering these systems with the utmost of security, but also from a reliability factor. So safety, reliability, and operational integrity are key and paramount. And it seems as though that for the last 20 years that I've witnessed personally firsthand is we've pushed a lot of things into a digital technology. We've moved away from just the standard electromechanical relays or the pneumatics that used to run things from plants to even hydraulic crane control with certain aspects of electromechanical. Things are so much digitized now, and we have remote access. So next slide.
I was going to say, you can see from Michael's uniform, even without going back to that slide, that he's no stranger to ports. He's a Navy intel officer and spent a fair amount of time at sea. So these examples and analogies that we're sharing in Marco's day job, living in the environment, was something that was partly what Mike Asante drew on, those examples when he was coming up with these concepts.
Yeah, and honestly, this countering cyber sabotage book that's out, Andy, that you helped co-author is a wonderful read, and it goes through the methodology that I'm fixing to break down for those that are in the audience, and the process involved, and how deep, how wide, and the breadth of what you're going to look at within your systems. So next slide, please. Key things here is that maritime transportation systems are targets, and I know, Andy, you did talk about this earlier. Huge kudos out to the folks here at Port of Houston that were targeted by a suspected nation state and from APT actors. So we do know that from a likelihood standpoint, we do know that ports are being targeted. Yesterday, I was on a good call that with the Maritime Security Talk with Chris Walsky, Mike Ziesmer, Julio Gonzalez, and another gentleman that was the key piece person there that was from one of the West ports. And the key thing here is that even though targeted, the preparation, the ability to determine and detect is highly critical. And so due to the timely response and actions, business operations were not impacted. That is a huge thing. But the key piece here is that if the compromise had not been detected, the attacker could have had unrestricted remote access to the network. And those are some of the things that you have to keep in mind, especially from your staffing. And there's some smaller port areas that are critical to your nation, and then there's going to be larger ones that may have the resources. So going back to likelihood, where we talk to folks saying, well, we've never been targeted before. We've been doing this for 30 years and never had an incident. You didn't have the digitized or digital systems that you did 30 years ago or 20 years ago or even 10 years ago. And Andy and I talk about this a lot, is that the last 5 to 7 years, many things have actually progressed from digitalization. And then post-COVID, or during COVID, we've been able to support the remote worker and the mobile worker with power of computing, network speeds, advancements. We've got 5G, we got so many different things and moving parts, is that now we're so interconnected, and we're going to even drive further interconnected with the left hand and the right hand trying to secure it. So it comes down to engineering practices. So next slide. Which then brings us down to the concepts of consequence-driven. Cyber-informed engineering is really looking at the functions that are critical and essential to your corporation, whether it's a port, it's a terminal, or a cruise line, whatever it may be in the maritime facilities. It's important to understand what that is and being informed, which from an operator standpoint, identifying those key points within a critical systems that are vulnerable to attack. And then the engineering is to leverage an organization's operational expertise. You run it, you touch it, you've worked with these systems a lot, understanding that process knowledge and try to engineer out cybersecurity risks is a very important piece and element to the CCE methodology. Next slide. And so when we look at the actual process, there are 4 phases that are involved. And so this methodology is really to establish a working relationship to protect the infrastructure and other national assets. So the process is a deep dive into your maritime systems, which does take time and does take resources, takes trusted and trained partners and facilitators to really do this actual methodology. But what it helps with is focusing on the impacts of potentially negative effects, degradation of systems, stranded assets, unable to move logistics from ports to transportation to rail, and understanding from a larger aspect of it what that ripple effect could be and what that actually could involve, right? So understanding that and that. So what's your area that's being affected and so forth. And I'll dive further into that, but just let's face the facts, folks, is that the impacts to the maritime domain by purposeful cyber means is sabotage, however you look at it. And so this methodology that was created by Idaho National Labs, that was co-created with Mike Asante, is really a strategy that compared to other methodologies where you have to try to identify likelihood, try to scale it, then try to determine a security level target, what is that going to look like and be. Your adversary doesn't care what your security level target is. Your adversary doesn't really care whether or not your likelihood is a 3 or a 4 or a 5. They care not. And so, Andy, I know you're smiling there because you know the aspects of that are certain and true, right? So
That's
next
for
slide.
sure.
So within the first phase is really understanding the areas impacted and developing high consequence events. And that could be unable to move cargo, unable to or have a blackout situation, electrification side of it. Ports are highly demanding on electrification, movements, autonomous. All these things are huge. In identifying what a high consequent is for your company or for your port or your terminal. Even marine terminals for oil and gas. What does that mean if you cannot load barges or offload or load out LNG for a country that's needing that cargo to be able to run their electricity? So there's a lot of things that are dependent, and the interdependencies are what really gets flushed out in phase 1 to be able to understand what that high consequence is. And when we talk about attack breadth, we're really just talking about what the extent to which a targeted technology or system is deployed, and that can result in adverse effects from an operational standpoint, and a greater span of impacted systems. So the more difficult the restoration following an adverse event, what does that look like for your company? Is that 3 days? Is that 5 days? Is that 10 days? Or is that even longer? And from a degraded standpoint, what does that impact to the population and to the nation, whether it's nation critical or client critical? So these are the things that you look at. The other part of it too is system integrity, understanding what it takes from that restoration effort, and what confidence do you have that it's actually restored from a system integrity standpoint, that it is operational and good. And I know, Andy, you talked quite a bit about CCE for the last, several years. And I know that that's one that folks get very vocal about, is the attack breadth and system integrity, and knowing what those areas look like. And then safety. Safety is paramount for every organization. Every organization has a safety motto or slogan, and they track their lost time incidents, their lost time accidents. But are they tracking their cyber components to that? When was the last near miss that you may have had from an organizational standpoint, and are you tracking those? So safety is paramount. And then looking at it too from a high consequence event is the cost, including restoration fees. What does that look like? So looking at the restoration costs and then developing and utilizing scoring criteria and thresholds is what you really focus on within phase one. So is it no effect whatsoever? Or is it a low to medium? Or is it a high or high effect uh, consequence that could impact? So next slide. And then in phase two, that is the system of systems. So really looking at the storage and access of who can get to your systems. And it's amazing. We always talk about these RFIs and the blueprints of what we're trying to secure, yet as a industry from a maritime standpoint, we often see blueprints, drawings, network architectures, even in RFQs. That are even sometimes posted publicly. And so we're trying, when we're looking at these system of systems, trying to make sure that we're not exposing these to nefarious actors with malintent, we have to make sure that we're securing these. The other part of it too is understanding what your data protection plan is how are you going to protect that information? And then understand what your unverified trust is. And so when we say unverified trust of your systems of systems and breaking those apart, I like to think of the exploded view of your site, whether it's your cranes or whether it's your terminals or your offloading or autonomous systems that you have in place, really looking at that from a architectural standpoint and seeing what blind unverified trust that you have. So that's like your example, your blind reliance upon your people, process, and technologies. We see that a lot, especially when you have roles and responsibilities that you have users with single login, full admin privileges, and understanding what that looks like in the remote access side of it. And so you have to really look at your systems of systems within this phase. And
It
it's
ends
all
up
about,
being, it ends up being, excuse me, it ends up being a lot like hope again. Like I hope that the vendor did a good job securing their stuff because we bought it, we deployed it, and we depend on it. I really hope they're doing a good job. But since I don't have the ability to check, I don't have the expertise or the time or the money to really interrogate that application, that software. I'm back to hoping it's okay. And if it's not okay, well, then it's not my fault really because it's their fault. At the end of the day, that doesn't matter though, because if your operations are taken out, the finger pointing won't matter that much at that point.
that's right. That's right. And that's something that we deal with often, especially in maritime systems, because most maritime systems has so many package units, so many OEMs, so many different devices that even within themselves from the OEMs, those vendors may have software builds of material that come from other countries or other divisions of other industries. And so really trying to understand what all that is really that system of systems analysis.
Pay attention if you're not from this world, the world of Andy and Marco or the cyber experts. Sometime soon, I think you'll be hearing about a term called the SBOM, the software bill of materials. Because as he's saying, you don't know what's in your stuff. No one's been required to put what the ingredients are in your compressor station, in your automated crane, in any of these things. But the SBOM is the software bill of materials. And if you think about your Kellogg's Cocoa Krispies, for example, a while ago, the FDA said, we need to know what's in here. That we're advocating for the customer, the consumer. And so now you can decide how much sugar you want in your bodies or your kids' bodies. The SBOM, fully realized, and it's in pretty extreme development right now, pretty accelerated development, will actually force vendors to tell you what's inside. And you can decide whether that's good for you or bad for you or what needs further investigation. It can also help you with your RFP process.
Yeah, exactly, Andy. And so within phase two, you're really setting up for the next phase. And the idea there is to reverse engineer everything that you have within your system, within your complex, within your port, your terminal, your facility, or even your vessel, your ship, or your drilling platform, is to understand and break that apart to be able to go into the next phase. And phase three, next slide, really gets into consequence-based targeting. And that is the targeting, the infection, the spread, and the effect. And so when we look at that is you're looking and targeting from a maritime perspective. So maritime domain scenarios to determine the paths, the targets, the access, and the information an adversary would need to achieve these events. And then the other piece of that is that when you have this team, because it is a team that's working on CCE as a methodology, because you're going to go all in with this, is to refine and develop the targeting requirements. An adversary would need to fully understand the attack surface and in detail, and consequently to carry it out. And so that is really looking to see what are the systems of systems that you identified in the previous phase, and then looking to see how would you go about it, and look at doing that from there. So from that consequence-based systems targeting, you look at the what you would need, where you can get it, and who has access. Right, Andy? Yes.
Yeah, sometimes when we do this, you can imagine, you may feel this in yourself, or you can imagine this in your colleagues. When we tell them that these things are possible and they're thinking not possible, we're all air gapped, everything is safe. Their arms are crossed, the metaphor for I'm not open-minded and I don't believe you. But as with them, we don't do this to people. We are arm in arm, whether it's INL or 1898 Burns Mac or anybody. This is something that happens with a client. It's as much on-the-job training as it is an engagement or an assessment. But as we show them what is possible, as we create the payload, create the kill chain and the payload that would deliver a knockout punch, and show them, without doing the actual punch, that this was possible. As you're going through that process, the arms unfold, and pretty quickly, or not, it's not quickly, but eventually, the people that objected most in the beginning, because they just couldn't believe this was possible, start to become champions of this process, and can come up with other scenarios and other ways that it would best be applied to their enterprise.
Absolutely, that's spot on. And I like this image. I've captured this image in the key piece there is that 20 years ago, 25, 30 years ago, you didn't really have Ethernet as a backbone or a backplane of your actual CPUs, your controllers, your auto, your advanced control modules. And as you can see in this picture, there's just Ethernet all over the place, and it's traversing a ship, or it's traversing a port or terminal, and that's you find that on all these systems nowadays. And you're thinking, okay, well, surely their safety system or their operations side of it has got some electromechanical or some form of mitigations or boundaries and barriers. And you find that they're still relying on the same systems or adjacent systems that are code-driven devices that are connected, that have possibly flaws in the software themselves and could be susceptible to TCP and UDP type attacks. So in layman's terms, it's connected. It has the capabilities, and it has software, and it has components to it. So from looking at it from an adversarial standpoint and a targeting piece is understanding how could you get to that device? What is the best way to do it? How can we infect it, spread it, and what is the effect that we're gaming for in that situation? And that's what phase 3 is all about. Next slide. And then phase 4 is really looking at the mitigation and protections and understanding what you have in place, but also to develop mitigations, protections to prevent, limit, respond to, and recover from an adversary carrying out these scenarios that have been developed. And looking at that from the standpoint of you've already pushed likelihood off the table, right? Likelihood is gone. It's a Boolean of 1. It's going to happen. We're not even going to toy around with that idea anymore. So you've gotten into the CCE, you've gotten into what your system of systems are, you've broken that apart, you've looked to see where you can actually now do your targeting. And this part of this process is saying the mitigation side of it and protections. And then in this final phase, it really is the priority is to take the possibility of the physical effect through cyber means out of the equation using engineering and or process changes. And process changes could be who has access, where it's located. It could be many different things. So I won't get into because I could get pretty long-winded on it. But the key piece here is that if you cannot or it is impossible to remove the possibility of the physical effect, then use a detailed targeting from the earlier phase 3, to detect cyber actor activity and implement any other types of mitigations that surround your high consequence event. And that is really the approach and the strategy that Mike Asante, Andy Bochman, and Idaho National Labs have really put forth is that approach. And I think it's important, especially from the maritime side of it, whether you're a port, terminal, drill ship, oil production platform, pipeline, whatever it may be, this can be used for all aspects of it. And
It's important to
MTSA
note.
facilities.
It's important to note that some people, when they hear us mention we're going to use first principles engineering or analog devices to protect a vital function, they start to hear analog or man or woman back in the loop, and they're feeling like we're going back in time and cast this as anti-progress, anti-efficiency. Almost everything Marco's describing as a mitigation is something that happens behind the scenes as a fail-safe or a stopgap measure. So you're free to continue automating and even turning to AI and whatever you need to be competitive and cost-effective and flexible as the world changes around us. Just these approaches can give the peace of mind to a given organization at a port and everybody that cares about it, that if and when it is targeted and a certain very vital piece is given the command by digital means to self-destruct and bring everything to a grinding halt, but that won't happen. The worst thing that will happen is the target will shut down gracefully. And that could be a disruption. It could be a disruption which should get people's attention and may cost some money, but it's so far from the disruption of long lead time to replace capital equipment being destroyed that would take weeks or months to replace. And think of the stoppage there. I'm thinking about Ever Given, which it doesn't seem like it was a cyber thing, but look what happened to the world when that happened. Look what's happening to the ports now as it disrupted from non-cyber means. So we are talking about resilience here. You may take a hit, but you won't be dead, and you'll live to fight and ship and receive shipments another day.
Right. And I think coming back to the beginning of the ports of the future, for those that are still in conceptual design and before you even get into the actual detailed engineering, it is important to go through this process or a similar process to be able to look at and say, how can we actually engineer out the risk? And it is important to do it there, because when you talk about cost, doing it later, once it's already running and operational, is going to cost you more time, more money, and then you'll more than likely have a lot of risk that you won't be able to mitigate unless you do it up front. And that's why this methodology is important from that standpoint. It comes down to engineering aspects. And I think that's what Mike Asante's point was. We have to engineer these cyber systems. Next slide. So in conclusion, and I think this is a build, if you wanted to build that out, Kyle, is the CCE does provide critical infrastructure owners, operators, vendors, and manufacturers with a focused bottom line approach. It helps you determine your most critical functions and identified methods an adversary could use to compromise your systems. And it helps evaluate your complex systems, that deep dive engineering and reverse engineering aspect. And it applies proven engineering, protection, and mitigation strategies to isolate and protect maritime industry's most critical assets. Because if you are a port, you are a terminal, and you are in maritime, you are considered critical infrastructure, and we need you to be secure out there. So, next slide.
Caveat: this is not the answer to all problems. This is not a fully bulletproof thing. We're not thumping our chest going, do this. You never have to worry about anything in your life again. It is, however, a way to become demonstrably more secure. And to be able, because it's demonstrable, you can see it, you know it, your people know it, and people you care to demonstrate that to, like regulators, like insurance companies, they can see it too. And so you'll never be claiming that you're going to be completely fine in all situations. But compared to the way we talk about demonstrating security now, which is by checklists and Q&As and taking people's word from it and hoping, it's a major step forward. Marco, any closing words? I have one more thing to say. I'll put it on the other end of.
No, I think this is, just encouraging folks to look at their systems holistically, and understand that what that likelihood is, and be prepared, and go through a step process. So thank you for your time. Go ahead, Andy.
Speaking of time, I think you said up front before we went live that we'll probably be done in 30 minutes. We both talk fast. And
30-minute our time.
I was thinking we talk fast, but we have a lot of words to speak at a high rate of speed. It may end up filling up most of an hour. And voila, here we are. Voila, here we are. There are some Q&As, some which I've attempted to address on the fly, some which I think we should touch now before or as we approach the top of the hour. The plug I wanted to make was Marco and I have both been involved in work of the think tank, the Atlantic Council, and some recent reports they have put out on maritime security that are quite authoritative. I want to say that in coming weeks, somewhere in the inter-holiday period, I think there's going to be another one that a brilliant maritime specialist, Dr. Ian Ralby, and I put together with help from others on the cyber risks to the energy systems. This is a little complicated. The energy systems that support maritime operations, including ports. So that's maritime, energy, cyber, and that'll all be coming out soon. And Marco had a hand in that as well. So be on the lookout from the Atlantic Council.
Absolutely. Yeah. So there are some questions in here. It looks like some were answered, right?
You have to see if you like the answers, though. Some guy who is in the middle of this thing just like threw out some stuff. Let's see if any of it sticks.
Yeah, I'm happy to ask a couple of these questions here.
Sure, go ahead.
That I know Andy answered, but and Andy, if you want to give a brief kind of overview to the answer, you can, and then Marco, you can go ahead and step in. But first question was, aren't threat, vulnerability, and consequence-based risk assessments the current government requirements for critical infrastructure owners, operators to assess and analyze security risks per the NIPP? While important, consequence mitigation seems to be only one leg of the three-legged stool.
What do you see in the field, Marco? I told the Joseph Myers that I agreed that is the current approach advocated by powers that be, and yet this is a variance from it. So what do you see people trying to do when you're in the field?
Well, I from what I see, they are doing risk assessments, but they vary. There's just so many different variances, and the part that makes it unintelligible is some of the corporate risk matrix that some of these companies actually use. Is that even even if a cyber actor was there, that they're showing, oh, it's all nice and green from our corporate risk matrix, and so it varies. And the problem is that yes, there are requirements in place with MTSA facilities, but some of the ports and terminals may not actually fall under that. And even then, it's reporting on vulnerabilities and things that you may have. So I do see the question where he says seems like it's part of a one-legged stool, and there is truth to that. It all comes down to the people, process, and technology, and doing these risk assessments. And the one thing that we've been working on, my company, is going out and doing verify and assurance assessments, just to see if people are actually following their own policies and procedures, and what are they doing, and what are the systems like. And so it all comes down to that. And if you have exposed threats and these vulnerabilities, what do you have in place to protect you from there? So
maybe this hopefully I'm addressing the spirit of the question, is that that government guidance is for a whole enterprise, all your systems, all your networks, all your processes and stuff. CCE is not for everything. In fact, if you do phase one right, it's for hardly anything. It's for just a handful of processes and functions and the systems that support them that you absolutely cannot live without. And so that's what you determine that in phase one. That's what you take through to the rest of it. So that the other things that various standards and government requirements would have you look at, you're supposed to still do that. That's still part of good cyber hygiene. But CCE is much more like a scalpel, focusing on things that you can no longer tolerate the level of risk that you're now carrying.
Right. Now let's see. So next question, Kyle.
Yeah, let's go ahead and move to this one. How do smaller, less mature, less resourced organizations begin to approach this process? We talk about software bill of materials It is a lot about how less mature organizations can actually utilize and consume them in an effective way. What tools or resources exist to help facilitate this type of thinking approach to risk?
Andy, I'll let you go first.
Yeah, okay. I'll start. I think Will, whenever I'm thinking about the smaller, therefore less resourced organization, I'm already feeling pain for the big organizations. Now you take away some of the capabilities that they have, and now where do you stand? You know, I guess at the base of it all is have a plan B. Figure out, still ask yourself the questions: what are the systems? What are our main processes that are most mission critical? What are the systems, whether they're on our premises or they're in the cloud, that were something to go awry, or we were to lose confidence in them, that we were the ones driving them, we would have to, that could seriously disrupt us or kill us. And both, to the best of your ability, figure out a plan B, how to weather that storm, and then not just write it down on paper or pixels, but practice it. Practice going through the storm once or twice. And again, I'm thinking of primarily ransomware here, but it applies to any significant disruption, whether you're targeted or not. How are you going to handle something that you hope doesn't happen? Well, go ahead and come up with a plan and see if you can live with it. And it'll know that it works when you've practiced it and worked out all the kinks.
Yeah, and that's spot on. And I think the only thing I would dovetail in on that is that even the smaller and even medium organizations have contracts, support contracts with their OEMs and their vendors, and lean on them. If they're the owners or the manufacturer, you should within your right ask for what that SBOM looks like from them for your particular system, since you may have an annual support contract with them. Say, hey, we're doing this for cyber. Here's an ask that we have. We'd like to know, what's in the system, and we'd like to utilize that as part of our support contract. And
don't forget the ISACs, the information sharing and analysis centers, ones that you have access to, or local authorities like the FBI. I often point people to. They're not all created equal, but some are pretty good, and they can be a nice source of helpful information that doesn't cost a smaller entity much or any money at all.
Right.
Marco, this next one is very port specific. So do you mind giving it a go?
Yeah,
what's the question?
I'll go ahead and read this aloud. In the current port cybersecurity, do we have a cybersecurity agent who is monitoring the process and isolate a part of port in case of a suspected cyber attack? If yes, does the agent receive some sort of explanation what type of attack and where it is?
So typically port operators and owners do have at least staff or augment staff to be able to do cybersecurity or support it, depending on the architecture, whether there's segmentation and things like that comes into question. But yeah, as far as isolating it, I think we've seen history where other ports here, like in the U.S., that have been impacted, were able to isolate. And then I think the latter part of the question is that if the agent receives some explanation, what type of the attack and where it is, I think working with your collaborating with your port partners, utilizing things, especially like your ISACs. There's MTS ISAC is a good group to work with. So information sharing, collaboration, InfraGard, in reporting to your Coast Guard and things like that. I see a lot of port efforts and collaboration going. So.
Irfan, thanks for that question. This second question, I am not sure I understand enough to hazard an answer. Do you have an intuition, Marco, what he's going for here?
Yeah, the question, and I'll just read it aloud.
Yeah, thanks, Kyle.
Yeah, no problem. Where can we get some ports data to test of cybersecurity algorithms if we've developed a port cybersecurity algorithm? I know throughout all of our conferences, everybody's trying to get their hands on data, right? Data. Everybody wants to get their hands on stuff to test things.
And so this is a great question. However, when you look at the consequence-driven cyber informed, this is the kind of information that we're trying to protect as well. So having a port operator say, here, please take this, take all of our information where we can gather asset inventory information, PLC information, programmable logic controller information. These are the types of things that we can protect. So from an answer to that is that if you work with your port partner and you have a contract and a NDA in place, I'm sure they can work with you on that. But otherwise, finding stuff in the wild is something that we're trying to deter against and protect against.
Irfan, one of the first parts, and anybody listening, of CC engagement is working out all the details on data protection to both parties or all parties' comfort, because the information that is generated is, as Marco said, super sensitive. And actually, along the way, you find out that stuff that you wish wasn't online in the open source, you find out all kinds of stuff is out there helping the adversaries already. So part of your get well program is to clean up things that either your organization has published or your partners have published or your clients have published, and get that off the internet. Stop making everybody's job easier for them.
That's right. Good questions.
Yep.
Yeah, very
Thanks.
good questions, and that brings us to the end of the hour. I want to thank Andy and Marco both so much for joining us today, taking the time, answering these questions, delivering this webinar. We really appreciate it. Marco's one you're going to be able to see at the Port of the Future conference for sure next year. Some information will be constantly pushed out your way, and we will follow up with these slides and recording within the next couple of hours. But Andy, Marco, thank you both so very much. Very insightful, very much appreciated.
Thank you, Kyle, Jessica, and WebTech, and everybody for taking a piece of your day and spending some time with us. It was a great pleasure.
Thanks for everybody for coming in. So
perfect.
Cheers,
Have
Marco.
a great day, everybody.
Cheers,
Bye.
Andy.
Be safe.